Okay, in this video, we are going to learn about the triangle sum theorem. Now, you may already know this fact, but we're going to establish the fact if you don't know it already. We're going to prove it, and then we're going to use it to solve some equations or solve for some missing angles down here. So this whole page is page 2 of your 12.1, 12.2 homework. This is all about this guy, the triangle sum theorem. The triangle sum theorem says that the sum of the measures of the interior angles of a triangle is 180 degrees. What that means is in any triangle, doesn't matter what shape it is, whether it's scalene or obtuse or right, the three angles, the inside angles, right, the interior angles, when you add them all together, they give you 180 degrees. Okay? That theorem you can find on page 589 in your textbook, and then the proof of it is on 590. And it's a pretty good proof, but I wanted to walk through it with you. I'm going to do it pretty similar to how they do it in the book. So if you want to look for that, it's on page 590, but I'm going to walk you through it, and then we're going to use it, okay? This actually is going to draw on something that we learned from chapter 10, which is parallel lines, stuff about parallel lines and transversals, which is actually going to be really helpful. So we couldn't get to this point without having gone through chapter 10. So this is just like our axiomatic system. We're building step by step, and now we can prove things about triangles because we have things about parallel lines. So if you notice in this figure, we have a triangle ABC, and that's our given, just that we have a triangle. And then you'll notice that there's this other line here, okay? And this line is drawn so it's parallel to AC. So we got this little red arrows indicating that this line BD is parallel to line segment AC, which we could extend into like a full-on line. So in this, what we're doing is we're just setting it up to prove that regardless of what shape this triangle is, these three angles have to add up to 180 degrees. So that's what we're after. We want to prove the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Okay? Now, first thing I wanted to talk about really quick, and this is just a super quick idea. It's a postulate that we kind of skipped over kind of quickly. It's not super important and it's pretty obvious. But the idea is, let's say I had this triangle, ABC. There's only one line that I can draw through B that's parallel to AC. Right? So if I draw a line that kind of comes this way, that wouldn't be parallel. There's only one way to do a parallel line through B if we want it to be parallel to AC. And that's called the parallel postulate. So we'll bring that up just really quick, just so you know. Okay, so the parallel postulate says if there is a line and the point not on the line, so we have a line L and a point not on the line, then there is exactly one line through the point P that's parallel to L. Okay, so if I had the black P and the black L just sitting there, there's only one red line I could draw that would be through P and parallel to L. So that's what we're using. It's called the parallel postulate. So this first statement here really is going to be, triangle ABC given, but then we're going to talk about the parallel postulate. Okay. And so what we're going to do is we're actually, let's say we just started out with this triangle. What we could do is we could draw or construct, spelled it wrong already. We can construct BD. We'll make that a line so that BD is parallel to AC. Okay. Let's see if this is any better without this on. Sorry, sometimes you get a little bit of glare off the page. Try something else. Okay, that's a little better. Okay, so the given here, or the justification is the parallel postulate. We can construct a line. There's only one line that we can construct that goes through B and is parallel to AC. So there we go. So now what I want you to notice is we have two lines basically, and they're cut by a transversal. There's actually two transversals here, right? And so that's going to help us out a lot. The next thing that we want to say here before we get too far into the parallel line ideas is that this angle 4 and angle 2 and angle 5, they have to add up to 180 degrees because this is a straight angle, right? So remember that we had an acute angle, right? We have a right angle, we have an obtuse angle, and then if we go all the way where it's just like two opposite rays, that's a straight angle. And the measure of a straight angle is 180 degrees. Okay, so 4, 2, and 5, it's kind of like a linear pair, but they're not a pair, it's 3 of them. So if we put all those together, we're going to get 180 degrees. So we're going to put the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. And the justification for that is, first of all, we know that BD, or that line, makes a straight angle. We also know that there's the angle addition postulate that says we can add up the little angles to get the big angle. So we're going to say definition of straight angle. And then we're also going to use the angle addition postulate. Okay. All right, cool. Now this is where it kind of gets interesting. So now we're going to look at these parallel lines and this transversal. I'm going to draw it a little more like a transversal. So if you ignore this line for a second, what you'll notice is 4 and 1 are alternate interior angles, right? They're on the opposite side of the transversal on opposite lines, and we know these lines are parallel. Therefore, angle 1 and angle 4 have to be congruent to each other because they're alternate interior angles theorem, right? So we're going to say that angle 1 is congruent to angle 4. Alt, int, oh, sorry. Let's at the same time, let's say another thing that's similar on the other side. So notice we have another transversal. We can extend these lines. So if we ignore this line for a second, we know that angle 5 and angle 3 are congruent to each other, right? Because they're alternate interior angles and these lines are parallel. So while we're at it, we might as well say that angle 3 is congruent to angle 5. And that's the same theorem, that's the same justification for both of those statements. It's the alternate interior angles theorem. Okay? So we may have to add a line here, that's okay. We know the measure of angle 1 equals the measure of angle 4, and the measure of angle 3 equals the measure of angle 5. That's just the definition of congruent angles. Okay, and now what we can do is we can do a substitution, right? Since angle 4, the measure of angle 4 is equal to the measure of angle 1, I can take this line and instead of using measure of angle 4, I can just call that measure of angle 1. I still got measure of angle 2, so we're rewriting this statement. So I replace this with measure of angle 1. Then we have this, and then we can replace measure of angle 5 with the measure of angle 3, because the measure of angle 5 is equal to the measure of angle 3. Okay, and that's going to equal 180. Oops, sorry, this should be a 3, not a 5. Okay, so we just rewrote this line, but we replaced this guy and this guy with what we know they're equal to. We know that 1 is equal to 4 because of the alternate interior angles theorem. We know that 3 is equal to 5 because of alternate interior angles theorem. This is exactly what we wanted to prove. We're just going to say this is the substitution prop of equality. Okay, so that's kind of cool because it kind of demonstrates again what an axiomatic system is all about. Right, we started way back when with just a ton of definitions. That's all we had is just definitions. And then from there we talked about vertical angles and how that works. And then we talked about corresponding angles and parallel lines. And then we proved alternate interior angles. So from alternate interior angles we can get this triangle sum theorem, which is kind of cool. That's just how our axiomatic system works. All right, let's do one more. So now down here, now that we've proved this theorem, we know that the sum of the interior angles of any triangle equals 180. We can use that fact to solve for missing angles or something like that. So in these problems here, you're going to use the triangle sum theorem to set up and solve an equation for x. Then we're going to use x to find the measure of angle A. Okay, so this is angle A right here. We want to find that guy. Okay, the triangle sum theorem says that if I add all these up, I should get 180. Okay, so we know that 73 plus x plus 51 plus x plus 70 has to equal 180. So we're going a little bit over into problem 10 here, but that's okay. Try to write real dark for you guys so you guys can see that. Okay, so just add all these guys up. That's it. And make it equal 180. Okay, from there, we're just going to combine like terms. So we have a couple x's, so 2x. And then we'll add up the angles. So we got 73 and 51 and 70. So let's add those up. 73 plus 51 plus 70. Okay, that is going to be plus 194. Okay, that equals 180. Okay. Let's keep on going. So now we want to solve for x. We're going to subtract 194 from both sides. And we're going to get 2x equals negative 14. Okay, that might seem kind of weird at first that we're getting negative numbers, but remember, we're just solving for x, which isn't an angle measure. It's just a variable. So we can have x be negative because we're going to plug it back in to get angle measures. So let's divide both sides by 2 to get x by itself, and it looks like x equals negative 7. Okay, cool. So all we got to do now, we have x, right? Solve the equation for x. Then use x to find the measure of angle A. So if we plug this back in, we get negative 7 plus 51 is going to give us the measure of angle A. So negative 7 plus 51 is going to be 46. Let's double check that real quick. Oh, sorry, 44. Good thing I checked. Okay, 44 degrees. Okay, and there you go. So you're going to do something similar on the rest of these. Remember that the square, of course, indicates 90 degrees or right angles. So now that we have this triangle sum theorem, you can just use the three angles, set them up, set the measures of the angles all equal to 180 when you add them all up. Solve for x and then plug it back in to find the measure of angle A. Just keep in mind that angle A might be in a different spot for each problem.